In this video, I'm going to review the Fall 2022 exam. The Fall 2022 exam is somewhat similar to the exam you'll see this term. It's slightly longer than the one you'll see this term, and there's a question on the Fall 2022 exam that you will not see on the exam this term. So let's just take a quick look at the questions. So starting with question one. Question one is a series of short answer questions. For your answers for these questions, you should try to be very brief. You don't have to write in full sentences. Point form is perfectly fine. So let's take a look at some of these questions. So question 1A, what is the purpose of a constructor? So a perfectly suitable answer would be to initialize the fields of a newly created object. So that's what every constructor should do. Remember, when you're implementing a constructor on the exam, you should make sure you set the fields of the object being created. 1B is asking you about utility classes, and it tells you some information. It says you don't make objects of a utility class type, and it's asking you, how do you make sure that when you make your utility class that people can't make objects of your utility class type? So the answer is that you insert some sort of private constructor in the class, and you don't provide any non-private constructors. So if your class defines a constructor, even if it's private, the compiler won't synthesize the public no argument constructor for you. So if you have only private constructors in your class, there's no way that anybody outside the class can call the constructor, and therefore there's no way for anybody outside the class to make an object of your type. Question C is asking about post conditions and what is the definition of a post condition. So remember, methods can have post conditions. The post condition for a method is just something that the method promises will be true after the method is finished running. Question D is asking you about class invariants. So remember, a class invariant is something that the class promises will always be true. So for the counter class, remember, all counters promise that their value will never be negative. That would be the invariant for the counter class. Part E is related to part D. So it says, imagine that you implemented the class counter and the field value was public. So remember, the value field represents the value of the counter. And the question asks you to explain why that field cannot be public in a correct implementation of the class. So the answer is, counter has an invariant on its value. The value is never negative. If the value is public, then anybody can change the value of the counter, which breaks the invariant of the class, which possibly breaks the invariant of the class. Part F is asking about privacy leaks. So remember, privacy leaks occur when you are can occur when you're implementing a composition. So remember, in a composition, if X is a composition of Y, then X has exclusive access to its Y object. In other words, X will never release a reference to its internal Y object. If it does, then that is what a privacy leak is. So a privacy leak occurs when a class So it occurs when a class incorrectly exposes a reference to one of its fields. If a class exposes a reference to one of its fields, then whoever gets the reference to the field can then change the state of the field. 1G is just asking you to interpret a UML class diagram. It's asking you, in this case, what is the relationship that it's trying to illustrate, and in this case, it's simply inheritance. So part H is related to part G, and it's asking you about the UML class diagram from part G. So it's asking you, so if A has a non-static field that's needed by classes B and C, what should the access modifier for the field be? And so technically public is a possible answer. So if a field is public, then anybody has access to that field, including classes B and C. However, in this question, because the relationship is inheritance, it's trying to get you to say that the field should have protected access. So remember, if a field has protected access, then subclasses of the class have access to that field directly by name. Question I is asking you to list 3 different interfaces that we studied in the course. There's many possible answers for this because we did create lots of interfaces and we implemented many of the standard library interfaces. So there's lots that you can pick from. So just to name a few, there is comparable. List, set, and map are all interfaces. And we created our own interfaces as well. So we had a stack interface, a simple list interface, and so on and so on and so forth, right? There's many others. If you wanted to pick some from the standard library, you could choose iterable and iterator, for example. Part J is another inheritance question. It's related to the concept of polymorphism. So remember, in polymorphism, an object has more than one type. And this is true for all reference types in Java except for the class big O object itself. Remember, big O object has no superclass. So for all other reference types, they all have a superclass, and that means that they have more than one type. So the types that an object has includes its own type, and the type of all of its ancestor classes, and the types of any interfaces that the type implements. So for the stack class, one of its types is stack, which is also down here. It has included as its types are all of its ancestor classes. So that would be vector, abstract list, abstract collection, and object. So that's 1, 2, 3, 4, and 5, plus all of its interfaces. So here we see that there's 1, 2, 3, 4, 5, 6 interfaces. So in total, Stack has 11 types. I believe that this question also appears in another exam, and in that exam it says the answer is 12. The reason it's 12 is because whoever wrote the answer double counted stack. So they counted stack here and they counted it again a second time here. The correct answer in this case, though, is 11. Part K. Again, this is another inheritance-related question. So this is related to inheritance and polymorphism. So objects have more than one type. And so in this example here, we have an object of type string, and it's being stored in a variable of type big O object. And it's asking you what is the declared type and what is the runtime type of OBJ. So the declared type of a variable is just the type of the variable. And so that's the type that's on the left-hand side of the equal sign in this case. So that's going to be big O object. Its actual type or runtime type is the type on the left-hand side. And so that's string. So the declared type is object. Runtime type is string. Part L is related to part K, and it's asking you, are the following lines of code correct, and to explain why or why not. So we create a new string object and store that in a variable of type object. And then we try to use obj to call a string method. That's not allowed. So remember, it's the declared type that determines what methods can you call using a variable. So the declared type of obj is object. That means using obj, I'm only allowed to call methods belonging to big O object. 2 uppercase belongs to the class string. Therefore, this code is not correct. So declared type is object. And 2 uppercase. M and N are both related to data structures. It's asking for the big O complexities of push and pop for an array-based stack, and then N asks for the same thing for a node-based stack. So for a pop, for an array-based stack, push adds an element to the stack. Now remember, when you add an element to an array-based collection, occasionally the array has to be resized, which means all of the existing elements in the array have to be copied into a new bigger array. And this is because arrays have a fixed size in Java. And therefore, the worst case complexity of push is going to be big O of n. For pop, when you pop an element off of an array-based stack, you simply adjust one of the fields inside the class. So in other words, you adjust the field this.top, which is just the index of the top element in the array. And so that only takes constant time. So worst case complexity for pop is O1. In a linked node-based stack, for push, you simply create a new node, and then you join the node up to the front of the sequence. And so the number of operations there is constant, so it's O1 time. For pop, all you have to do is disconnect a node from the sequence, and that also occurs in constant time. So that's also O1. Part O is asking to explain why inserting an element into the middle of an array-based list has worst case complexity in big O of n. So the reason is because if you insert into the middle of an array-based list, you have to move all the elements from the insertion point onwards 1 position to the right. In the worst case, you have to move all of the existing elements in the array 1 position to the right to make room for the inserted element. A common misconception in this question is that students think that you have to move to the element or move to the index where you want to insert at. And that's not true in an array-based list. In an array-based list, you can access an element by index in constant time. So there is no moving to the insertion index. That is what you would have to do in a linked list. But this isn't a linked list, it's asking you about an array-based list. And that's question 1. So question 2, you will not see a question like this on this year's exam because you've already been tested on this material. I'm going to answer this question anyway because it's not very long. So this question is essentially asking you to essentially asking you about the comparable interface and to implement a version of compare2. And so it's using this range value type. So range value, which I think you've seen on one of the assignments, I think the second assignment, is just a value in this case, is an integer value where the value always lies between some minimum and maximum value. So a ranged value between 0 and 10 would be any value between 0 and 10. Okay, so part A, the question starts out by explaining what equals does for two range values. So it says two range value objects are equal if their values are equal. So in other words, the minimum and maximum value of the range is not considered or are not considered in the equals method. So if you were to write out the implementation of equals, it would look something like this. So here's all the regular equals stuff, right? And then the two ranges are equal if their values are equal, right? So return, I guess you could write this as this dot value equals other dot value like that, right? It only looks at the value. So it wants you to implement compare to, where two values are compared for order according to the following set of rules. So essentially what the question is saying is that so for compare to, it wants you to return 0 if the min, max, and value of both of the ranges are equal. So one way you could do this is to test whether the min, max, and value are all equal, and then return 0 if that's the case. So we could, let's do it this way very quickly. All right, so if this min equals O min, and this max equals O max, and this value equals O value, we can return 0. Okay, now if that set of conditions is not true, then we know that one of the two ranges is less than the other range. So it says R1 is less than R2 if the value of R1 is less than the value of R2. So we could test that right away too. This R1 is less than this R2. Okay, so sorry, not this R1. This value is less than the other value. Then we know that this range is less than the other range, so we have to return a negative value. You can pick whatever value you want. I'm just going to return -1. Similarly, if this value is greater than the other value, then this range is greater than the other range. So if this value is greater than the other value, right, I need to return some positive value. I'm just going to return 1. Right. Now, if you reach this point here, you know that the values are the same. And so now it wants you to compare the widths of the two ranges. So the smaller range is the one with the narrower width. And this is where things get a little bit, you have to be a little bit careful when you calculate the width. So what most students would probably write is they would, this width would probably write this dot max minus this dot min. Right? And unfortunately, this gets you into trouble because there's no restrictions on the value of max and min, which means that other than the maximum has to be greater than the minimum. So that means that this difference can overflow. So for example, if this dot min is integer min value, then any value of this dot max subtract integer min value is going to be a value greater than integer max value. And so this is going to overflow. Sorry, that's not true. Sorry. So if this dot min is integer min value, then if this dot max is any value greater than 0, then the value will overflow, right? So for example, 1 minus minus, integer min value, is bigger than integer max value, and that overflows, and now your width is calculated incorrectly. And so you need to compute the widths using a type that is bigger than int, or can represent a wider range of values than int. So long would be the appropriate integer type for this. Double would also work. When you compute the value as a long, you have to make sure that this difference is computed in long arithmetic. So one way to do that is to add 0 as a long value to the front. Another way to do this is to cast one of the two values to long. And that will force the calculation to be computed using long arithmetic. You have to do the same thing with the other width. And so okay, now I need to compare this width and other width. You could use an if statement like we did above, but it's easier to use the compare method from one of your wrapper classes. So the easiest way to do this is to do return long dot compare this width and O width, like that. So the compare method inside of the wrapper classes will compare these two values and return an appropriate integer value that is compatible with compare to. So in other words, if this width is less than O width, it'll return a negative int. If this width is greater than O width, it'll return a positive int. And if they're equal, it'll return 0. And so that's you could have implemented, when you compared the values, you could have also used, integer.compare to compare the values instead. Part B is asking you to give an example that proves compare to is not consistent with equals. So here you have to remember what consistency with equals means when it comes to compare to. And so compare to is consistent with equals if when x equals y is true, x dot compared to y returns 0, and if x dot compared to y returns 0, x equals y also returns true. And so in this case, that's not true, right? Because equals only looks at the value, right? So in equals, we only compare the values, but compare to compares the value first, and then it compares the widths if the values are equal. And so what that means is that you can have two ranges that are equal. So here I've got the range, my one range value whose min and max is 10 and 20, and the value is 15. I've got a second range value, min and max is 0 and 100, and its value is 15. So as far as equals is concerned, these two things are equal, right? But as far as compare to is concerned, right, the width of the second range is much wider than the width of, or is wider than the width of the first range. So R1 is less than R2. So when we write R1 dot compared to R2, we should get a negative number. And public static. Sorry, we're running the wrong class. Just a second here. There we go. Right. So is R1 equal to R2? Yes. Does R1 compare to R2 return 0? The answer is no. So there is an example where compare to is not consistent with equals. And then finally, it's asking you to provide a correct and reasonable implementation of hash code. So this is not really an interesting question. So for hash code, remember what hash code does. It takes an object and converts and produces an int value representing the object. So typically what you do is you take the fields of your object and you somehow combine them together to produce an integer value. And so in the lectures, you were told to use this method called hash, objects.hash, and you pass in the fields to compute a hash code using the values of the fields. So you might be tempted to write the following, right? And this is the only trick to this question. So if you wrote something like that, your answer would be wrong. And the reason it's wrong is because equals only uses the value of the ranged value. And so remember what the requirement for hash code is. If two objects are equal, their hash codes must be equal. So if you only look at the value in equals, but hash uses min and max and the value, then if you have two ranges that are equal, so they have the same value, but they have different mins and maxes, the hash code for your two ranges will probably be different because their hash codes are being computed using the min and max. Whereas in equals, you're only considering the value. And so what that means is two objects that are equal will probably have different hash codes, and that breaks the contract for hash code. And so you can't use the min and max in this case. You can only use value, and that's the only really interesting part in this question. Question 3 is essentially an aggregation/composition question. And so question 3 presents you with a class that is fully implemented. So the class has a collection of elements stored in a list. It has a constructor. The constructor does the right thing. It initializes the list by making a new array list. Size simply returns the size of the list. The push method takes in an element as one of its inputs, and it adds the element to the list. Pop simply removes one of the elements from the list. So part A asks you which one of the following statements are true. Okay, so it's is a list stack an aggregation of elements, or is it a composition of elements? And so the way that you can determine which one of these is true is to look at a method that either takes in an element or returns an element. So push and pop are both good to look at here. And ask yourself, are either or both of these methods, are they making a defensive copy of the element? If it's making a defensive copy of the element, it's going to be composition. So when you look at this method here, we're using elem directly. It's not making a new copy of elem. Therefore, you know right away it's not a composition. So you know that A is true. It must be an aggregation of elements. Now, is it an aggregation or a composition of a list? So again, you go through your methods and constructors, and you look for when the list is being used. So in size, the list is being used, but we never return the list, right? We return the size of the list. We don't return a reference to the list. Push uses the list, but it doesn't return a reference to the list. Pop, again, uses the list, but it doesn't return a reference to the list. The constructor makes a new array list. And so when you look at all of the methods and constructors, you can see that a list stack has a list, and it's the only thing that ever has direct access to that list, right? It doesn't expose a reference to a lems, therefore it's a composition of a list. And so this is going to be A and D, right? Aggregation of elements, composition of a list. It now asks you to implement the copy constructor for the class. So here's list stack. It wants a copy constructor, so you need to remember, what does the copy constructor look like? So public list stack, so it's a constructor. Now this says that the copy constructor copies another list stack object. So here, the parameter is another list stack object. I suppose this should be list stack E, like that. There we go. Okay, so now part B would be marked based on how you answered part A. So if you correctly said that your a list stack is a composition of a list, then the marker would be expecting you to implement the copy constructor as though it were a composition. So what does every constructor do? It initializes the fields of the class. So for sure, we're going to make a new list for elems. Like that. Okay, so if you're going to copy another list stack object, then what you want to do is you want to copy the elements from the other list stack object. So the easiest way to do this is to pass in the other list of elements to the constructor of ArrayList, and that will copy the elements from the other list into the new list, this.elems. So that's the simple way to do it. The hard way to do it is to make a new list, is to make a new empty list and then to manually copy over the elements yourself. So perhaps using a loop. So for each element E in the other list, add that element to this.elems. Right. So there would be a so there is the copy constructor implemented, assuming you had assuming you answered that it was a composition of a list. Now, this also assumes you answered the question saying that it's an aggregation of elements, because we're not making a copy of each element from the other list, right? We're simply using the reference from the other list directly. So if you answered it's a composition of elements, you would now have the problem where you need to make a copy of this element E. And there's no way to do that. So you cannot write the following. Right? That's not allowed. So here we're trying to call the copy constructor for this type E. But that's not allowed because the compiler doesn't know what this type E is. It's generic, right? So the big E is just a placeholder. And so it can't check, does type E have a copy constructor? So this won't compile anyway. So for sure, this isn't going to work. And that would be the correct answer, assuming you said it's a composition of a list. If you said it was an aggregation of a list, then the marker would expect you to answer the question as though it should be an aggregation of a list. And if you're saying it's an aggregation of a list, then you would write other.elems like that. Right? So in other words, you would not make a new list. You would simply set this.elems to be the same list as the other stack's list of elements. Right? So again, the correct answer in this case is to make a new array list, copying the elements of the other, stack, like that. Question 4 is an inheritance question. So this one uses the counter class that we studied in the course. So let's look at this class here. Okay. So it wants you to implement the class resettable counter. So a resettable counter is just a counter where you can reset the counter back to 0. And the resettable counter keeps track of the number of times that it's been reset. We're going to need some way to keep track of the number of times it's been reset. So what we're going to do is we're going to add a field to the resettable counter class that counts the number of times that it's been reset. The advanced method is also different than the counter version. So the counter version of advance adds 1 to the counter, and when it hits integer max value, it wraps around to 0. The advanced method for resettable counter adds 1 if possible, Otherwise, it stops at max value. So it's like the stopping counter we implemented in class. So when you implement your class resettable counter, it's a subclass of counter, so we must write that it extends counter. Our resettable counter needs to keep track of how many times it's been reset, so we need a field. So we're going to add a private field. The number of times it's been reset is an integer value, so I'm going to use int, and I'm just going to call this resets. We need a constructor. The constructor initializes the counter to 0, so we need to add public counter. Okay, now this is an inheritance question, so you have to remember when you're making a subclass, the very first thing you do in the constructor in the subclass is call this parent or call the superclass constructor. So we need to call a counter constructor of some kind, and in this case there's only one, so we have to call that counter constructor. To call the superclass constructor, remember, use the keyword super, right? Round brackets, pass in whatever arguments are required by the superclass constructor. The superclass constructor expects the value of the counter, right? And the value of our new resettable counter should be 0, so we have to pass in 0 here. Right? You're not allowed to write super round bracket, round bracket. That calls the no argument counter constructor, and there is no argument constructor in the class shown here. Right? And there's even a sentence here saying so. Right? So you should assume that the counter class has only the constructor and methods shown above. Okay, so what else? So once you've called the superclass constructor, now you can finish setting the fields of your class. So we should set that value there. So the number of resets for a new counter is 0, right? We haven't reset the counter yet, so we should set this resets to 0. Now the next two methods are pretty straightforward. So when you reset a counter, you reset its value back to 0. So how do we set the value of the counter? Well, inside the counter class, there's a field called value. It's protected, so resettable counter has access to it directly. So we can write this dot value equals 0, like that. Remember, we're keeping track of the number of times we reset the counter, so we should add 1 to this dot resets, like that. Num resets simply returns the value of this resets. And finally, advance simply needs to advance the value of the counter by 1 if possible. And then, if it can't advance the value of 1, it should stop at integer max value. So there's many ways to implement this method. You have access to value directly. So you could implement the method simply by trying to add 1 to value and stop, and don't add 1 if you cannot. So for example, if this value is not equal to integer max value, and that would be fine, you're done. So that's one solution. An alternative solution is to realize that the superclass also has an advanced method that adds 1 to the counter. If you call the superclass version of the method and it sets the counter to 0, then you know that wraparound has occurred. So an alternative way to implement this method would be to call the superclass version of advance and then check, okay, is the value of the counter 0? Right, if it is, that means we wrapped around from integer max value. So we have to set our counter back to integer max value. like that. So that would be another way to implement the method. Here, when you're calling the superclass version of the method, you have to write super.advance. You can't write this.advance or just advance because that will call the method itself, and this will become infinitely recursive. So if you're inside a method that you are overriding and you want to call the superclass version of the method, you need to use the keyword super in front of the method. So that would be another way to implement the method. There are other ways you could do this as well. So I'll just leave it at that. Oh, a common mistake in this question is that students will, so number one, they won't extend counter. So that won't be there. It has to be there because it says make a subclass. Another common mistake is that students will add or repeat a field from the superclass. So they will add their own value field to the resettable counter. And now what ends up happening is your object ends up with two fields called value. And this will cause problems in your class. Any method inside the counter class that touches or uses value will end up using that value. Any of your methods in resettable counter that use value end up using this value. And so what you end up with is a counter that has two different values. Depending on which method you call, you'll end up using one of the two values. They won't be synchronized, and your counter won't behave the way it should. So never repeat a field that is inherited from the superclass, right? So never do this, right? The field value belongs to the class, belongs to the superclass. It should not be repeated in the subclass. So don't do that. Next question is a data structure question involving a linked sequence of nodes. So this one says it's using linked stack. It doesn't matter what the actual class here is, whether it's linked stack, linked queue, or linked list. All of these things work more or less the same way. They are a linked sequence of elements. So it's important that you understand how do you manipulate a linked sequence of nodes. That's all this question is trying to get you to is trying to ask you about. And so this question is asking you to implement a method called bottom that returns a reference to the bottom element of a stack, or null if no such element exists. Remember, in a stack, we have access to the top element, and that's it. If you want to get to any other element, you have to follow the sequence of nodes, moving to the node that contains the element of interest. So for bottom, we need to move to the last node in the sequence. So ignoring the special cases, let's write a loop that starts at the top node and moves to the bottom node of the sequence. So we're going to start at the top node. So I need a variable of type node. Usually you call it n. You call it whatever you want, right? And we're going to start at the top node. Okay. Now, the way all of these loops work is you write a while loop or a for loop. Either one will work. I'm going to write a while loop, right? And now you're going to loop until you reach the node that you're looking for. Right, so I'm going to leave the condition blank here for now. Inside the loop, all you're going to do is move n to the next node, right? And so to move n to the next node, you just write n equals n dot next. All right, so when we reach the end of our loop, right, what we want is n is now pointing the bottom node. So that's what we want to be the case, right? We're going to ensure that that's the case by writing in the correct loop condition here. Let's assume that n is pointing at the bottom node. We want to return the bottom element, right? So, or the element in the bottom node. Remember, the element in the bottom node is stored in the field elem, right? So here we can simply return n.elem like that. Okay, so now the question is what goes here, right? So we want to move forward in the sequence as long as there is another node in the sequence, right? So we know that there's another node in the sequence if n dot next is not null. If n dot next is null, then n is the bottom node. So here we want to run the loop body as long as n dot next is not equal to null. Right? This simply says there's another node after n. If there is, we're not at the bottom node yet. So move to the next node. Right? When we reach the bottom node, right, n dot next will be null. Right? Because we're at the bottom node, there is no node after the bottom node. So we don't want the loop body to run. N is pointing at the bottom node. We return the element that's there. The only thing you have to be careful of here is the following. So here we set n equals to this dot top, and then we use n to access the field next. This is fine as long as n itself is not null. Right? If n is null, then null.next is results in a null pointer exception. And so when would n be null? Well, when is the top node null? When the stack is empty. Right? So if you have an empty stack, you have to return null. You cannot let this loop run because that loop's going to cause a null pointer exception. So if this is empty, sorry, I guess we don't know that this class has an isEmpty method. So if this size is 0, so in these questions, you're only using the information provided by the question. So if the stack is empty, there is no bottom node, therefore we should return null. And there's your correct implementation of bottom. I guess we can run it here. So this makes a stack, adds A, B, and C to the stack. I guess we can print out T dot like that. That should work, right? Oh, wait. The reason it's not working is because the declared type of stack, the declared type of T is stack, and it's not linked to stack. Right? Link stack has a bottom method. The stack interface does not have a bottom method. So that's why that wasn't compiling. Let's see what we get here. So if our stack is CBA, then the bottom node is A, which is correct. So it looks like that method is working correctly. Also in these types of questions, you might see stuff like this. So there could be restrictions on what you can and cannot do, right? So this says don't use push or pop. Right? The easy way to, the easy way. So one way to implement this method is just to pop the stack until there's one element left on the stack. Then you know that there's, then you know that you've reached the bottom element. Grab the value in the stack off the top of the stack. And then push all the elements back onto the stack, right? So this question, these types of questions want to know whether or not you can manipulate the link sequence directly. So there'll often be some sort of restriction on the type of things you can and cannot do. All right, last question is a data structure question. And so this one says, this one's asking students to implement a fixed sized set. So a fixed size or fixed capacity collection is a collection that has some maximum size and it can't grow beyond the maximum size. So this question is trying to not ask you how to grow an array-based collection. Now on the exam, you might have to know how to grow an array-based collection. This question is specifically asking you not to worry about that sort of thing. So it's asking you to implement a fixed capacity set. Right? So it gives you an interface called mini sorted set. It has a few methods in it. So there's size, so how many elements are in the set. Last, what is the last element in the set if it exists. Contains, right? Does the set contain a particular object? And then it has an add method. So add an element to the set. In bold, it says don't implement add. Because it's a bit of a pain to implement add because this set is sorted, right? So if you look at the description of the class, it says a small fixed capacity set that keeps its elements in sorted order. If you have to keep the elements in sorted order, when you add, you have to find the correct insertion point. The question asks you to implement the set using an array somewhere. Does it say array somewhere? That partially implements and provides a set that maintains. Do not implement. Oh yeah. So this one's, yeah, okay. I guess you could, if you wanted to, you could use a linked sequence of nodes. You cannot use a list. So you're not allowed to use any classes or interface from the standard Java library. So you can't use a list or a set directly from the standard library to implement this. So your choices are to either do this with a linked list or an array. I'm going to do this with an array because that's the easiest way to do this, I think. So let's implement this class. Okay, so there's our interface. We need to implement the class MSSSet, so mini sorted set, that uses an array. Okay, so when you go to implement this class, you're going to put in the name of the class. You're going to put in the element type, and then you're going to put in the interface that we are implementing. So this implements the mini sorted set interface, like that. All right, now this is going to complain. It's going to complain that a bunch of methods are missing. That's fine. We're going to add those methods, right? So we need a size method. We need a last method. We need contains. It says not to do add. Add's here, and it's implemented already. And I think it says we need a constructor. Yes, and it needs an overridden equals. Okay, so the constructor should initialize an empty set. All right, so we need something to store the elements in. We're not allowed to use a list or a set or a map or anything like that. So our choices are an array or a linked sequence of nodes. I've already said I'm going to do this with an array. The class is generic. So when you implement one of these classes, a generic collection, a generic linear collection, your array type is always of big O object. Right, so I'm going to make an array of object, and I guess we'll just call them elems. Let me quickly look at what I did inside equals. Elem, okay. So that's going to be our array. Also, when you implement this sort of thing, remember that an array in Java has a fixed size. So an array of size 16 always has 16 things in it, whether you put something in there or not. Right? So an array of 16 ints, when you make a new one, you get 16 zeros. If you make an array of 16 objects, you get an array with 16 null values in the array. The array doesn't know how many things are in it, it only knows its length. So if you need to keep track of how many elements are in the collection, which you probably always want to do, you need a field to keep track of this number of elements. So we're going to add a field. I'm going to call it size. That's just the number of elements in the set. Okay, let's start with a constructor. So the constructor should initialize an empty set. So public, sorry, I don't know what just happened there. Strange. I don't know what just happened there. Private int size. Okay, public. Okay, so public, the constructor, so name of the class. No argument constructor, so no arguments. What does the constructor do? It has to initialize these two things here. So for elem, we're going to make an array of object. Right. How big is it? So the question says 16. So here we're going to use make an array of size 16. The set is empty, so its size is 0. So there's your constructor. Okay, now we need the methods from the interface. So the method size is easy. You just return this dot size. Last returns the last element in the set if such an element exists. Okay, so public. Okay, so for the last method, what you have to remember is that the set keeps its elements in sorted order. So you know where to find the last element in the set, right? Because you know the number of elements in the array. The index of that element is just size minus 1. So all you have to redo is return the element in this elem at size minus 1, assuming the size of the array is greater than 0. Okay. So if this dot size, if it is 0, there is no last element. So the interface says it should return null instead. Okay. Otherwise, we're going to return this dot. Right? So the element sitting at this dot size minus 1. Okay, and it complains, right? So here, Eclipse is complaining because our array type is big O object, but the return type of the method is of type E. So the cast here is needed. So we have to convince the compiler that, in fact, the element in the array is, in fact, does have type E. So we need the cast there. Right, and this is the thing that always is required when you're implementing an array-based collection, and your array type is big O object. Right, you always need to cast back to the generic type. Contains. So contains is pretty straightforward. You know how many elements are in your array. So you're simply going to loop over the number of elements in your array, and you're going to compare each element of the array to obj using equals. If equals returns true, then you can return true immediately. If after your loop is finished, you know that you've looked at every element in the array, none of them are equal to obj, so now you can return false. So write a little for loop. I want the loop to run for the number of elements in the array, so this dot size. Each time through the array, I'm going to grab an element, or I'm going to grab element I from the array. So here we can do object O, like that. I want to compare O to obj. So if they're equal, return true. Right? If they're not equal, you can't return false. So that's another common error in this type of question. Right? You only know that the answer is false after you've examined every element that's actually in the array. Right? That happens after so you know you've examined every element once the loop is finished running. So if you haven't returned true and the loop finishes, you know that the element you're looking for was never there in the first place, so you return false. Things to watch out here for: you have to use this size here. You cannot use this elem.length. Right, that is incorrect. Right, this will cause the loop to run 16 times every time. Right, remember, if you start out with an empty array, an empty set, all the elements in the array are equal to null. So when you get the elem out of the array, O will be null. Null equals anything will cause a null pointer exception, which you don't want. Right? So this has to be this dot size. Another way to fall into the same trap is to use a for each loop. So if you try to do this, that will also, this dot elem, right? That loop will always run 16 times, right? For every element in the array, right? Well, that array has 16 things in it, so that loop's always running 16 times, right? Again, that's going to cause a problem if O ever becomes null. So don't use a for each loop in this case either. Have to use a counting style loop. You have to make sure that you don't run more than size times. Okay, so the question says don't implement add, right? There's why you don't have to implement add, right? Implementing add on the exam is a bit tricky. It's not very hard, but it's a little hard. So this particular exam asks you not to implement add. It does ask you to implement equals though. Now for equals, it's always the same thing. There's a bit of a complication in this case though. So when you read what equals, what the question is asking you for, it's asking you to implement equals for your class. So that's MS set. But it wants equals to also work for any kind of mini sorted set, right? So not just an array-based sorted set, but any kind of mini sorted set. So you have to use the interface type here, and that complicates things a bit. So in equals, we can always start out by testing if this and obj are the same object. If they are, you're going to return true. Now, to test whether or not obj is one of these, you have to use instance of. So here you're going to ask, is obj an instance of a mini sorted set? And notice the funny question mark inside of the angled brackets. So this is from one of the lecture slides that we didn't get to in the course this year. On the exam, you could just write that and it would be fine. Similarly here, there's also that funny question mark. And here, there's the funny question mark. Notice that if you delete the angled brackets and the question mark, Eclipse flags this as possibly being as a warning. And you get this funny error or funny warning here. It's not an error, it's a warning. That probably won't mean anything to most of you. But this is just an artifact of how generics were implemented in the language. So for now, just ignore you can ignore the angled brackets and the question mark. If you try to write E, that Eclipse will flag that as an error. And again, this is because of the way that generics were implemented in the language. So if you want to keep Eclipse happy, either leave off the angled brackets or use angled brackets question mark. On the exam, it doesn't matter. It wouldn't matter what you wrote. So use instance of, check whether or not obj really is a mini sorted set or not, right? So if it's not, you're going to return false. Next step is always the cast, right? I need to cast obj to a mini sorted set. And I'm going to store that in the variable other. Okay, so the question says two sets are equal if they have the same size and if every element in the set is also in the other set. So first thing you do is compare the sizes of the two sets. If they're not equal, then the two sets are not equal. The next step is you want to, for every element in one of the two sets, it doesn't matter if you use other or, in this case, you have to use this set. For each element in this set, you want to ask, does the other set contain this element? Right. So for every element in this set, does the other set contain this element? Right. You know that you can call other, you know that you can call contains because the mini sorted set interface has a contains method. So other.contains guaranteed to work. If that's false, the other set does not contain an element that's in this set, you know that the answer is false. If it's true, you can't return true, right? So if the other set does contain this element, it doesn't mean that the sets are equal, right? It means you have to test the rest of the elements still. So after you've tested all the elements, now you know that every element in this set is also in the other set, so now you can return true. And so there is the correct version of equals for this class. Yes. If you're wondering why add is throwing an error, it's because um, because the sets are sorted, we need some way to compare the elements in order to maintain the sorted ordering of the sets. So to compare two reference types for order, you use compare to. But in order to use compare to, our type, our generic type E must implement the comparable interface. And that's another reason why you weren't asked to implement add. It's because to specify that the type E implements comparable interface, you need to say something like that. I think this is extends, sorry. Extends, in this case, our generic type. You want to say implements here because this is an interface type. Unfortunately, because of the way that generics work in the language, that word there is extends, which is confusing. But that's just the way it is in the Java language. So as soon as you put that change in there, the compare to error now goes away. Everything's fine here. Again, for the purposes of this exam, the expectation is simply that, and don't implement add. Right? And so there's your complete class. Does this ask for toString? It doesn't ask for toString. ToString is here. If you run this class as it's written, oh yeah, add's gonna, okay, so let me put that fix back in so that we can actually run this. This will in fact run. There you go. So you can see here that as you add the strings to the set, they are in fact kept in sorted order. All right, and so that's it for the review of the exam. The exam this year is, again, it is comparable to this particular exam with the exception of question 2. You won't see a question like question 2 on this exam. You were already asked about that on the second test.